Good morning, good afternoon, good evening, wherever you are. Welcome to the CIQ webcast. For those of you who have been with us before, welcome back. For those of you that are new, we appreciate you coming. We appreciate your time. Go ahead and like and subscribe so you can stay up to date with what we're working on and what we're doing. My name is Zane Hamilton. I'm a Director of Solutions Architecture here at CIQ. And over the last few weeks, we've been doing several of these. If you didn't see last week's with Greg Kurtzer talking about Werewolf, go check it out. It was a great talk. This week, we're going to be talking about containerization, and we're going to be talking about Apptainer in particular. So I have a couple of guys with me, Forrest and Ian. Welcome, Forrest. Welcome, Ian.
Hello.
So, Forrest, you've been on here before. Most of these people know you, but why don't you go and introduce yourself?
Hi, everyone. My name is Forrest Burt. I'm a high-performance computing systems engineer here at CIQ. I've been a user of Singularity since about version 3.03 or so, when I used it to deploy containerized workloads across some high-performance computing architecture at an institution I was previously at. So I'm very excited to be here discussing Apptainer and to have seen the transition from Singularity to Apptainer there. So thank you for having me, Zane.
Thank you. Ian, you're new to the channel, so welcome. We appreciate your time. Tell us about yourself.
Yeah, it's great to be here. So my name is Ian Kaneshiro. I'm a software engineer here at ControlIQ and a maintainer of Apptainer. So I first got started with Apptainer in its previous form as Singularity back in 2018 when the project was undergoing a rewrite from version 2 to version 3 in Go. And so I was involved with the initial version 3 release and have been involved with the project ever since.
Awesome, thank you. So I think we should probably level set a little bit and let's kind of define what we mean when we're talking about container. Kind of how is Singularity Apptainer different? How is it the same? Just a little bit of kind of level set, if you don't mind.
Sure. So we can start off with what is a container. And from my perspective, and I think the way that users of Apptainer use containers, it's really a way of packaging an application and including all of the application dependencies in a way that's portable across systems. So if you build a container on one system, you should be able to run it on another system because all of the shared libraries and things like that an application might depend on is actually packaged within the container image and brought around with it to whatever machine it's being run on. I would say the primary use case that users of Apptainer reach for containers for is for high performance computing workloads. And so the requirements of these environments are different from what you would typically see in environments that run Docker, where you need a hard separation of users by POSIX permissions. And so that means you can't have a root-owned daemon spawning containers that any user can connect to and control. So with Apptainer, this allows users to spawn containers as their user, and all the processes spawned by Apptainer stay as their user and are actually unable to escalate privilege at all. So
kind of staying in that same vein, why would someone choose Apptainer for their HPC environment? I mean, you gave some pretty good examples, but is there any other reason or real kind of dive into that a little bit if you don't mind?
Unique things about Apptainer is just the image format that we use. It's slightly different.
Oh, you have lost Ian.
Uh-oh.
Welcome to live webcast. Forrest?
Am I back?
Nope. There you go.
There we go. Welcome back.
Okay. Yeah. Sorry about
over
that.
Completely from that answer. We lost you early on.
Okay. Yeah. So one of the unique things about Apptainer is the image format that it uses. So most of the container ecosystem, and actually all of it, to my knowledge, uses container images in the format of a rootfs directory. And so the image itself is stored as a tar and then extracted into a directory and then used directly from there. For Apptainer, we actually have a squashfs file system inside of our CIF images, and we mount that directly using a loop device. And this actually leads to some beneficial performance on shared storage systems because it minimizes the metadata lookups on those types of file systems, which is very useful in HPC environments that tend to use those kinds of storage systems.
Excellent. So, sorry, go ahead, Forrest.
I was just going to say, Apptainer also has a big focus on integration over isolation. There's a big focus in high-performance computing environments on being able to enable different kind of specialized pieces of hardware and software to be used by applications that are inside of a container, rather than try to isolate the container from the host. Apptainer actually works to integrate the capabilities of the host within the container, and so you can do things like run MPI stacks out of it, be able to interface with GPUs and things like that. Kind of common aspects and pieces of different technology found in an HPC environment can be pretty easily integrated into an Apptainer container and ran across that architecture. So that's another kind of big pull of Apptainer to HPC.
Excellent. So one of the things that I really want to talk about with you guys today is that transition from Singularity to Apptainer. I know I say Singularity a lot of times now. I catch myself saying it pretty much all the time. So it's new to me. I just want to understand a little bit, what does that migration look like when you're moving from Singularity to Apptainer?
Sure. So I think I'm back. I had to move locations for better connection. So the migration from Singularity to Apptainer kind of has two aspects to it. There's what the system administrator needs to do in order to install Apptainer and retain the type of configuration that it had the container system had in its previous installation with Singularity. And then there's the user aspect, which is really just about migrating user configuration that was used by Singularity to be exposed to Apptainer for basically continuity. So I think Forrest has a demo for those two aspects that he can go into.
While he's firing that up, Ian, is there anything specific that you have to do? Do you have to rebuild that from your definition file as you're moving from Singular to Apptainer, or can you just run the same?
I think you're talking about the containers themselves.
Yeah.
Correct. So for the migration itself, we're talking about, just to be clear for everyone listening, we're talking about the actual host machine that the Apptainer program, or formerly Singularity program, is installed on in order to run containers. And then Zane's question is about users using containers that have already been built with Singularity with Apptainer in a new installation. And the answer to that is there's no rebuilding or changes needed. Apptainer will run all of your Singularity built images just as in the same manner as Singularity would run them. So one of the core things about doing this rename of the application is to minimize impact to users, and using the same container format and ensuring that old containers will work with Apptainer, as well as containers built with Apptainer will work with Singularity, was very important in order to make sure that you don't have disruptions to how the community uses containers.
So there's backward compatibility as well. It's not just from Singularity.
Yeah. So if your system is using Apptainer and your colleague has Singularity installed on their cluster because they haven't upgraded yet, if you build a container with Apptainer, you're going to be able to share that with them, and they'll be able to verify your results and do things like that.
Excellent. Forrest, I think you're going to show something. I kind of cut you off. I know we have a question out there about other use cases. Let's let Forrest get through this, and then we'll dive into that. You guys, feel free to post questions in there. We'll take them. Obviously, it's live, so interaction is fantastic. We appreciate it.
Cool. All right. Well, yeah, I have a real quick demo to kind of go over the components of that migration, like Ian just mentioned. Can everyone see this terminal screen here all right?
I can see it.
Cool. All right. Well, I'm sitting here on a VM. This is basically just running Rocky Linux. And so what I'm going to show you here is kind of the system and the user side of this migration. This Rocky machine has Singularity installed on it. You can see I can do Singularity -- version, and you'll see we have version 3.83 on here. You can see that in just a moment I'll go ahead and run Apptainer. And what we're going to see happen here is, first off, there'll be a notice printed that's going to say something to the effect of there's still a Singularity configuration directory found out there, and that doesn't appear as though the sysadmin in charge of this server here has migrated those configuration options from Singularity to Apptainer. And then you also see a message come up that shows some info about some of my user Singularity configurations being moved over to Apptainer. And then you'll see a couple of messages that describe exactly what is being moved there. So I'll go ahead and run Apptainer for the first time. This is, as I alluded to, the first time I've run Apptainer on this virtual machine. So you'll only see, for example, one of these migration messages once, the user side one. The system side one will continue to appear until that migration is done. So I'll show you that in a moment. But we'll go ahead and run Apptainer for the first time. And we'll see that up here we have a few messages, namely this user local Etsy Singularity exists. Migration to Apptainer by system administrator is not complete. So as I mentioned, that's the system side of the migration, notifying you that's not complete. And then we also have these detected Singularity user configuration directory messages about a public and private PGP keyring, and those are about those being migrated. If I go to my If I go to my per user Singularity file that I have here in my user home, and I do, let's see, there it is. And I do this, you can see that I have 2 existing PGP keys sitting in there. And now if I look at .apptainer, which didn't previously exist before I ran this command, you can see that we have ls apptainer keys. And we can see that those keys have been migrated over. So that is how your user configurations will get moved over to Apptainer when you run it. When you want to do the kind of sysadmin side of it, we'll navigate to user local etc, and we'll just take a look at what's in here. You can see that we have Singularity and Apptainer. If we take a look at what's in Singularity, you can see we have the system Singularity configuration files in here. So these are things like singularity.conf, the library lists for GPU support, that kind of thing. If we want to go ahead and migrate our configuration over, that's just as simple as doing cp singularity. Actually, I'm going to need sudo on that. So sudo cp singularity, singularity.conf, and then we'll land that at apptainer/apptainer.conf. So as I mentioned, if you have custom Singularity configuration files you've done over time, we can do this to migrate them. And then once we've moved over everything that we need to move over from that user local etc Singularity, we can go ahead and I'll just take the nuclear option here. We'll do sudo rm rf singularity to get rid of that file entirely. That'll get rid of it. We'll go back here. And then when I run Apptainer, you'll see that we don't get that sysadmin migration message anymore. So you'll see up here at the top, we don't get that per user message because that's already been moved over. And then because we just moved the system stuff over and got rid of those Singularity files, that we don't get any more messages saying that the migration is no longer finished. So the transition overall from Singularity to Apptainer is pretty simple. It's basically just moving over your configs that you need to do on the system side, but pretty simple overall. It's a pretty seamless transition.
So there aren't really any lingering issues when you're transitioning from Singularity to Apptainer that you've noticed or run across, are there?
No, not really. It works pretty seamlessly. If you're working with RPMs, you may have to do some uninstallation there of the Singularity of a previously installed Singularity RPM because the Apptainer one will want to install over that. So you might have to do that, but in general, the instructions are out there for how to do the install of Apptainer, just there on the GitHub, and installing that from source and such is pretty simple. Or using the RPM if you want to go that way. So. One of the big points of the transition and the work that's been going on and kind of the engineering side of that thus far has been to ensure that that backwards compatibility is pretty seamless. And so thus far, that has pretty much gone well, and there's not too much else you have to look at there. Ian, do you have anything you'd want to add to that, or is it pretty much seamless at this point?
Nope, you covered it. And if there are any issues, we'd love to hear about it. I think in the description, there's a link to the Apptainer GitHub. And so you can post an issue if during your migration you come across problems that need to be addressed.
Very good. One of the things that we keep running across, or I keep having brought up in my discussions, and a lot of that is outside of just HPC, but kind of in the enterprise space, is what else can be done with Singularity? What other use cases outside of HPC are we seeing?
So I would say any use case where you need to have the ability to access a lot of the resources on the host. So what most container systems goal is to give you the view of your container as if it was a VM. So as if it was isolated from the host and its own thing. And so the container process basically doesn't have any real concept of anything else on that machine other than what was exposed to it very intentionally. Whereas Apptainer has the concept of integration over isolation. So by default, we do things like expose host file systems and host devices into the container to make them accessible, because the core use case is really about getting the most out of the hardware that you're running your container on. I would say outside of HPC, there's kind of, I'm not sure which way to go with that question, because when I think of HPC, I usually think academic, but there's a lot of enterprise workloads that are moving towards more HPC style. And some enterprises have always been in an HPC kind of arena that have been doing real world modeling in order to do simulations of basically the world around it, whether that's doing structural analysis or computational fluid dynamics. Those types of workloads have always been important outside of the academic community in order to do engineering work.
Forrest, I would also, anything? Sorry, go ahead, Ian.
I would also say Apptainer has some interesting features related to signing and encryption, where if your use case requires things like being able to guarantee that the container that you're using was created by the holder of a PGP key, you can do that with Apptainer very easily. What Forrest showed in his demo was moving a public and private keyring, and so that can be used with Apptainer in order to check to see if a container image, a CIF image, which natively supports these types of signatures, has been signed by a particular individual, and whether it's been signed by an individual that you might require in order to run on your system. So we have the concept of an execution control list related to signatures. So an administrator could say, I only want these identities to be able to run, or to be able to build containers that run on my system, and then that'll be enforced by Apptainer itself. There's also features around container encryption. So we encrypt the container file system and all of the application data encapsulated within that container. And that allows you to have not only encryption in transit of the container image, but also at rest on the node. And it's only decrypted within the memory of the node when it's actually run for execution.
Very nice. I think there was another question that just popped up about, there we go, for migrated Apptainer. Any other file directories need to be migrated or changed for us as you're going through that, or just that Singularity directory?
I am going to pass that off to Ian. Those are the ones that I'm aware of you have to do. Ian, are you aware of anything else that you need to do? Just moving those system files and making sure that your per user configuration is over?
No, what I'll do is clarify a little bit on the system administrator side of things. So the one main change for the Apptainer configuration directory, I think it's called sysconfigdir in our build system and our RPM packaging. The actual main configuration file was previously called singularity.conf, and now it's called apptainer.conf. So you will need to do a file rename. All the other files are named identically as they were for Singularity installations, and so you can actually just move those over directly without a rename.
So it seems like this whole thing is set up to be very easy to maintain. So maintaining an Apptainer environment seems fairly straightforward. Am I off?
That's one of the goals, not only of this rename, but of the project itself, is to make the workload of the administrators administering these clusters easier. So if there are sharp edges or things that are problematic for administrators, we want to hear about that in order to help alleviate that.
But usually whenever I think of something being simple, I also think of limitations that come along with that. Well, are there limitations with what I can put into an Apptainer container, or number of applications I can put in it? I mean, what are the limitations of it?
I would say that the limitation is probably more practicality than anything. There's not really a limit to what you can put inside of that file system. It's pretty extensible how you can define what you want the container to do on build, and you can basically install things into it on more or less, the same procedures that you'd be using on the host. There are caveats that are related to how containers technically work, but for the most part, you can basically do anything that you would do on the host. So I personally have never met an application that I couldn't containerize with Apptainer. And like I said, it comes down more into the end of, what's going to be practical, how what's going to be the best moving forward to be able to manage that container. If it's got a lot of different software dependencies, things that are going to have to be updated, maintained, stuff like that. It basically just, comes down to practicality and how much maintaining you want to have to do of that container, depending upon what exactly you put in it. But no technical limit really to what you can put inside of one.
And to continue on that thread, one of the limitations I would say is not actually with what you can put into a container, but how you can run the container. So Apptainer is a Linux container platform, which means you need to have applications that are able to interact with a Linux kernel for system calls. So you couldn't take a Windows application or a Mac OS application and put it inside of an Apptainer and be able to expect it to run, just like you wouldn't be able to install those on Windows, on a Linux host and expect them to run natively. You could try using something like Wine to do emulation, but for the most part, users of HPC, which is kind of our core crowd, are already using Linux, and so it's a very natural fit.
Sure. So making that statement really means it's very kernel dependent.
It's kernel dependent in terms of the kernel flavor, but with respect to kernel versions within Linux, it's actually very portable. We recommend having a kernel of 3.18 or higher, which is a relatively old kernel. And the kernel itself, as a project, has done a great job of being very stable with its system call interface, which is the reason why Linux containers are able to exist in the form that they do.
So I have a question about environment variables. Can you see those environment variables after your container or Apptainer has been executed?
Yes. So Apptainer will automatically forward environment variables from so to back up, Apptainers are usually spawned from a user shell or from like a batch script. And so once Apptainer is called, it'll actually take the environment that is currently existing where it was called and propagate that to the container environment. You can also like explicitly set environment variables that you only want to be exposed within the container by using a particular set of prefixes, an Apptainer env underscore, and then the environment variable name and the value. But in general, and in the standard use case, Apptainer will automatically forward environment variables to your container. And you can use flags if you would like to prevent environment forwarding in order to stop that from happening.
All right. So this is an interesting question. I haven't ever really thought about this before, but will there be an Apptainer hub, kind of like Docker Hub, Singularity Hub, or we?
Yeah, so I think that's a good question. And I think it really comes down to what are the needs of Apptainer and of CIFs in order to be stored and used by the user base. So the nice thing about the image format being a single file is you can use any form of storage that is able to handle blob storage essentially. So Singularity Hub is, I think, in read-only archive mode right now, so you can still pull images and run them. But in terms of if you need a place to push CIF images, you can use things like blob storage systems like S3, and you can also use OCI registries that support the OCI artifact specification, which is essentially a way of using OCI artifacts as arbitrary blob storage. And so that fits nicely with kind of current infrastructure. If a registry supports that API, then you can store both your Docker images and your Singularity images in the same registry side by side.
All right, so I know, Forrest, you talked about MPI applications a little bit earlier. When we start looking at running Apptainer and dealing with file systems, how does that work? Can you use external file systems, or will it handle external file systems?
Most definitely. And this kind of ties in a little bit with what we were saying about that integration versus isolation approach. Apptainer is basically sitting on your server as a single runtime. There's no, as we've talked about, daemon-based system, anything like that images have to be, built against. It's basically just the single Apptainer runtime that runs the single Singularity image file container files. And so when you're actually using Apptainer on a server, you can basically just treat your Apptainer containers as just the same as you would any other file on that, and run those with that runtime. So, and then as I said, that also kind of gets into integration over isolation. Apptainer, as we've said, is built to interact with that external file system, with regards to host devices and host capabilities, host software stack, stuff like that. There's an ability to bind files in, for example, from that host file system if you need to do that, and those can appear at container or at a location in the container that you'd like them to be at. So Apptainer in general doesn't really have a problem dealing with external file systems. It's really meant to integrate with those external file systems, so that's one of the primary points of it.
And I'll just add on to that to say that by default, Singularity mounts the user home directory into the container. So for usual work with HPC resources, that user home directory is typically a network storage system, and there's also usually a /share. And so Singularity will mount like your home directory, and so you'll have all of your user configs that you would normally have on that node inside of the container. And so it'll usually just feel like you've swapped your user space operating system when you use a Singularity container or Apptainer container. Saying the wrong name.
I have a really brief.
I'm not the only one.
Yeah, still new.
It happens. Really quickly, and I have something that I can show that off, kind of being the same user inside and outside of the container, if we'd like to do that real quick.
Yep.
I think this kind of leads into the next topic I wanted to get into, is kind of that multi-tenancy. How does this work in a multi-tenant HPC environment?
Mm-hmm. Yeah, so just to kind of show you what maybe a typical flow would look like for getting a container from some type of registry out there onto your server and then being able to use it with Apptainer. I'll just go ahead and show you. We'll do just something really simple here, an Ubuntu container. So we'll do Ubuntu focal, and let's go ahead and pull that.
And while he's pulling that, I'll just say that what's happening right now is he's actually pulling a Docker container from Docker Hub, the default Ubuntu image, or I guess the focal tag. And in the background, we're quickly building that into a CIF and caching it within his home directory in order to use it as a CIF for future commands. So you can use any OCI image to use as a source for an Apptainer container.
And one big thing to note about when we're doing this is that there's no concept of layers essentially inside of an Apptainer. While Docker and containers from other runtimes are built as kind of a layer format, Apptainer essentially takes all those layers and squashes them together into that single squashfs container file system. So there's no concept of layers in it, and it kind of decreases your attack plane there for cybersecurity and other purposes. So that's useful. But you can see that this has gone ahead and finished. We've created a CIF. If I do an ls, you can see that we have Ubuntu Focal over here. I'll go ahead and do really quickly, just cat this text file here so you can see what's in that. If I go ahead and do, whoops, I almost started typing Singularity. If I go ahead and do Apptainer shell, and then I put in this container here to get a shell into this container, you'll see that I get an initial error because I'm sitting on a VM and this happens. Really quickly, I'll do cat etc os release. So you can see that I'm here on Rocky. If I do a who am I, you can see that I am test, my just test user on this VM. If I go ahead and do Apptainer shell, you'll see that I'm now inside of this container and I have a shell into it. If I do cat etc os release, you can see that we are now on Ubuntu. If I do an ls, you can see that I can still access all of my standard files here. I can cat that right there. If I do who am I, you'll see that I'm still test in here. And I can even do things like, for example, this is more test text, and append that to this file that I have here. And then I can even do this. You'll see that those are both visible inside of the container here at this file right here. So you'll see that we've managed to append to that successfully, and we've created this other file successfully. And if I exit out of the container, you can see that both of those files are also present. And I can do this to see the file that I created right then, so we only expect one line. And then checking the other one, you can see that we have both the original line and the one that I added there. So point being here, as we discussed, in the multi-tenant environment of an HPC cluster, the standard way that Apptainer runs is to make the user inside of the container the same user as outside of the container and preserve all those access controls and stuff like that. So if I go, once again, just to show you, if I go into this container and I try to say cd/root, I get permission denied. If I try to do this, you can see once again permission denied. So I remain my same user with my same user's permissions inside of the container. There's no elevation or anything to work out there. So in the multi-tenant environment of an HPC cluster, that's how Apptainer works to preserve access controls and make it a viable option for people to deploy their workloads with.
And one thing I'll add there is just that the processes that are spawned by Apptainer are using a process. I don't know the right word for it, but we set a parameter called PR no new privs, which basically means that that process and any descendant processes have no ability to gain any additional privilege on the system than they currently have. And typically, this actually makes running any kind of application inside of an Apptainer container safer than if you ran it just as your user on that system, because sometimes you might have capabilities assigned or the ability to use set UID programs and things like that. So this actually just blocks all escalation.
The recent, for example, PK exec vulnerability that came out when tested in Apptainer, as I believe we have a video out there of, trying to exploit that inside of an Apptainer is just shut down natively because of its security model. So there's a real world example of how Apptainer kind of increases the security on your system beyond that of which that's available normally.
So one of the question that came in, and I'm not sure I understand the question fully, but it's asking, talking about build remote. Will there be, I'm assuming it's, will there be the ability to build remote?
So the The API, so what that was essentially an API that is not widely adopted within the community, and to the point where we can make an open standard. It's solely for a commercial organization's cloud platform. And as a part of our migration to, migration to the Linux Foundation, we needed to remove proprietary APIs from our application. And so we had to remove that one in order to be compliant. I would say that most of the benefits of remote build are actually something that you can replicate with what we call our fake root feature. So on standard installations of Apptainer, when you build, you can use the -- fake root flag. And what this will do is allow you to run your build as if you were a root user inside of the build environment when you're still actually not on the system. So it's still safe to do, because the primary use case of the remote builder was to do container definition builds, which required you to be root on the system in order for things like package managers to properly work, since they do usually a straight user ID check to make sure that they're 0. Fake root allows these types of builds to progress.
Very good. Thank you. I know this one, we talk about this, Forrest. I know you and I talked about this one before, but does Apptainer support, or does it have support for GPUs?
Absolutely. GPUs are one of the pieces of hardware that Apptainer is built to support because those are a massive high-performance computing use case. So at the moment, there's native support inside of Apptainer for both NVIDIA and AMD GPUs. When we were looking at those system configuration files earlier, you may have noticed an NV liblist and a ROCm liblist file. Those are maintained. Those are essentially what the container needs in order to be able to support GPUs inside of it. That's a list of libraries that essentially have to be bound to the container when you want to run a GPU application. Apptainer has a specific flag, --NV, that brings, for example, those NVIDIA libraries and stuff into the container to make them available for applications that need them. So yeah, Apptainer absolutely supports GPUs. That's a huge high-performance computing use case. So it even has native support in it for the 2 major GPU manufacturers out there.
That's great. So Ian, I have another question for you since I have you here. Is there anything specific that I have to do to Apptainer to get that involved with my HPC job scheduler?
Oh, from using it with like a batch scheduler, like Slurm
Yes.
or PBS or those types of things. So yes. Not really. You just need to include those inside of your batch scripts in order to take whatever application you would normally run within your batch system and basically add the Apptainer exec with the container image you want to run inside of your scripts, and that will automatically go ahead and spawn those containers on the fly as if you would spawn any normal application when your batch scheduler goes and runs that script on a node.
Very nice. Thank you. So now that Singularity is Apptainer, is there anything else that's going to change? Anything to look forward to?
Sure. So I would say the main new feature is currently an experimental feature, and it's going to be within V1 of Apptainer. It's currently in the release candidates as well that are out right now. And that's the ability to checkpoint container instances using a project called DMTCP. So this is a project that allows transparent checkpointing for dynamically linked applications. And so this will give us the ability to do things like run a container instance on one node, and if for some reason that node, that container job either needs to be migrated because maybe that node has an issue and there's concern that it might fail during part of its job, you could checkpoint that container instance and then go ahead and start that container instance on another node, assuming they both have the same shared storage system and your home directory is available on both of those nodes.
Very exciting.
And kind of broadly with the future of Apptainer, there's a roadmap out there that kind of describes some of the features that we're looking at. I know, for example, I'm really excited to see kind of increased ability to use Apptainer with like some more specialized high performance computing hardware and software and such that's coming out right now. So I know that Apptainer has a really, really kind of exciting future ahead of it with regards to what we're doing with high performance computing technology. So kind of more broadly on the roadmap there, very excited to see where that goes and how some of our new features, that we kind of been talking about on our roadmap and stuff get implemented.
One of the questions I have for you guys is why did Singularity get renamed to Apptainer and then moved into the Linux Foundation? What did that achieve?
Sure. So the rename is actually a direct consequence of the decision to move into Linux Foundation. So when the opportunity arose to move into Linux Foundation, basically we reached out to the community and said, hey, if you want to be involved with the future of this project, please get back to us, because we wanted to be able to talk about this kind of move, not in a public forum, not like super secret, but we wanted it not to be public in order to like generate hype at that point. So we wanted to get those involved within the community and invested in the future of the project to be able to be involved in the decision-making process of that move. And so we went ahead and sent out basically a document, I think it was, that articulated what would be necessary in order to join the Linux Foundation. And one of those things was a rename of the project, because the Singularity name itself is something from pop culture and is impossible to trademark. I'm sure that makes sense to most people. So we needed to have a name that the Linux Foundation could hold a trademark for in order to protect the project. So we asked for suggestions for future names and what they thought of the move. And when we got all the feedback back, it was clear that moving to Linux Foundation was the right move. And so we had to do the hardest thing programmers can do, name something. And so we sent out a poll to those community members, and Apptainer won. And so that's how we ended up with Apptainer within the Linux Foundation. And so I'll say the reason for moving into Linux Foundation, a lot of the benefits are really about ensuring that the project stays within the open source community and can't be controlled by a commercial entity. Linux Foundation does a great job of ensuring projects are open source projects, and are any interested contributors or parties can be a part of those communities. And so that's really important to the Apptainer community. And it also gives us the ability to cross-pollinate with some of the projects within the Linux Foundation or under the Linux Foundation umbrella. Within the HPC scope, like we would love to be closer with projects like OpenHPC, as well as within just the general container ecosystem, which is primarily kind of cloud dominated. And so organizations like the CNCF have a lot of interesting initiatives and projects, and we would love to be have those as potential integrations.
Excellent. So you've mentioned the community and people being involved in that. How do people get involved in the Apptainer community?
Sure. So I think in the description, there is a link to our website, the GitHub repository, and our Slack. And so I think the most accessible way for most people is to just join that Slack and say hi, say what you're interested in. If you have any questions about the project, you're always welcome to ask questions in there. If you have issues where you're running into problems with the Apptainer program itself, you can go ahead and either ask those questions within the Slack channel, but you can also post issues within our GitHub repository. So that's kind of where we do all of our tracking of issues and make sure things get fixed and things like that. So that's a better location for placing an issue itself.
Excellent. So I don't know if we have any more questions out there. If you have a question, post it. See if we can answer it real quick while I have these guys' time. And if we don't, I just want to thank you for joining. Thanks, Ian. Thanks, Forrest, for spending some time with us. Forrest, do you have anything else you wanted to show or talk about?
Just that, with that increased push for containers in the cloud, and kind of that discussion of, containers and job schedulers and such like that, not to imply too much, but, job schedulers and HPC, it's traditionally kind of a field that containers have struggled to go into for the reasons that we've discussed here, the security model, the specific needs of the environment and stuff. So I just want to really quickly point out that, with this new revolution in HPC that's going on, the movement to containers and everything, something that we are really big on here at CIQ is kind of, mass orchestration and such of those containers in that HPC environment. And to that end, we have something very big that we're working on in that regard. And so we're very excited to kind of bring that to the broader market. So keep an eye out for that out there.
So we just had one pop in talking about or asking about new features and updates in Apptainer over Singularity. I think we kind of touched on that a little bit with it being able to basically suspend a container and move it if you needed to. Is there anything else, Ian, that you can think of?
No, I would just say that one of the things to look at for Apptainer is that functionality overall is going to be improved, because if you're using one of the older versions of Singularity and haven't migrated yet, all active development and bug fixes for the projects is going to be going into Apptainer. So if you have any issues, Apptainer is more likely to contain the fix for that bug.
Excellent. Well, guys, if we don't have any more questions, we will wrap this one up. Appreciate you coming. Looking forward to next time. I think probably 2 weeks from now, we'll have another topic for you. So Ian, appreciate the time. Forrest, as always, it's good to see you guys. And thanks for joining. Don't forget to like and subscribe. Appreciate it.
Thank you all. Bye.
Bye-bye.